All right, so let's do an example. Example number 1. Take a second and write this down. We're going to draw a picture. Always, when in doubt, draw it out. All right? Rhymes, so it has to be true. Let's place an object 5 centimeters in front of a concave mirror with a radius of curvature of 20 centimeters. And answer the following questions. Where is the image? And what is the magnification? And when we answer the question, where is image, let's answer, is it real, virtual, upright, inverted, all that good stuff. So first let's draw the mirror. Recall the cave shape. It's like that. You don't have to draw these hashes, but I like to. And let's put an object in front of it. Recall that the radius of 20 centimeters means that the focal length, of course, is half of that. So the focus will be here. The object will be here. Focus is at 10. Object is at 5. That's an O. It's supposed to be an O. O is 5. The picture is necessary only for one thing. And that is to remind us that a concave mirror is, drum roll, convergent. Therefore, the focal length is positive. Pop quiz, is O positive or negative? Don't look too far in your notes. So remember, real is positive, virtual is negative. The focus is where the light actually is, so it's positive. The object is a real thing, so it is also positive. Now we simply write the equation down. And plug in accordingly. O is positive 5. I is the question. And F is positive 10. Simply subtract 1/5 over. Feel free to use a calculator for that, or you can use an old-fashioned common denominator. Ooh, common denominator, oh my gosh. So 1/5 you can change to 2/10. Com denom, right? And then we end up with 1/10 minus 2/10. tenths is negative 1/10. Don't forget, the most important thing to remember is this is 1 over I, so that means you gotta flip and you get I is negative 10 what? Centimeters. So let's not worry about the position yet. We're going to do that in other videos and other lessons. Since it's negative, though, we do know and can qualitatively state a lot of important things that we can write down right now. Specifically, it's negative, meaning, don't look too far, it is virtual. And since it's virtual, it has to be upright. Just like if you looked at yourself in a mirror, you would see yourself upright on the opposite side of the mirror. So it's virtual, therefore it's upright. Those will always correspond, no exceptions. And of course, we can now solve for the magnification. Negative I over O. I, of course, being negative 10. O, of course, being positive 5. Negative negative means a positive 10 over 5, which is 2. So, what the heck does this mean? Well, the positive means it's upright. Positive magnification. I already figured that out, though, because we knew virtual meant upright. The 2 means it's twice as large. Boom! Which means that if this were height h, our image would be a height 2h. So that's how to interpret this. The positive does not mean necessarily that it's bigger, although in this case it is, but you could have a magnification of positive 1/2. What would that mean? Well, we'll explore that in another problem. But I'll tell you right now, to make it easy, the positive means upright, and the 1/2 would mean it's half as tall. That would be a miniature version of self. Versus this case, you'd have a magnifying version of self. Like you would in a funhouse mirror or something similar. So it's virtual, upright, 10 centimeters away, twice as tall, again, upright.